Hello, this is Seth Gleason. Currently, I am working on our Altera 2D, our capstone project, and right now I'm working on getting the opcodes put into this LCD screen so they can be useful. And we have our addition set up. Basically, right now I have the A value being able to be switched. And like if you see, I'm switching the A value down here by up and -1, and it changes both of these hex values and also the LCD screen. And I've been working on this for quite some time now, but we can also do it with subtraction, even though subtraction's a little finicky. Right now we have a glitch where it's really the actual subtraction value is doing 7 minus 31, which it should equal -24, but since this is like a revolving, it's 256. I believe that's 16 bits. Yeah, I believe that's 16 bits, and basically it does 7 minus 31 equals 232. But I'm going to change this to make it so it's 31 minus 7 equals, I guess that would be 24. Yeah, that would be 24. So yeah, I still have to work on this subtraction. But also, I'm doing multiplication, integer division, shift left, shift right, rotate left, rotate right, all these logics, the comparisons, and I'll show you our multiplication right now. Multiplication is 0, 0, 1, 0. So 31 times 7 is 249. I'm going to check that math. Okay, so there's also I guess there's also a glitch with our multiplication, because I don't know. Wait, maybe if I go like this. Hold up. I think sometimes it's finicky. Sometimes it's finicky. Here, we're gonna make it times. We're gonna do 31 times 2 at first. Okay, hold up. We're gonna start this back over. Cause like it should work. Okay, look, this one right now. For some reason, it's a little bit finicky. Where, okay, so right now it's 3 times 0. We're gonna put it up to times 7. Okay, and then we're gonna change our. Here we go. Right now we are on switch 11, switch 11, which controls the A value. And here we go. 3 times 7 is 21. 7 times 7 is 49. 15 times 7. Damn, that doesn't look right either. Oh, wait. 15 times that. I don't think that's right. I don't, honestly, there's a glitch going on with our multiplication, and I'm not sure what it is, but that's just something I'm going to be working on. And our integer division right now is 0, 0, 1, 1, which, let me get this thing set up. Alright, focus. Okay, and just like the subtraction, our integer division is backwards. So like right now, it is 15 divided by 3 equals 5. But I'm eventually going to go and switch, or we're going to switch these to make it 15 divided by 3. I think in order to fix this, we're going to have to go and I believe we're going to have to change our ALU code. We're going to have to the division is right here. We're going to have to switch these, I believe, in order to make this work right. And then after that, I haven't started working on these yet, but the shift left, shift right, rotate left, and rotate right. I have a plan on how to do it right here. Here, we're going to have a shift left. This shift left and shift is going to be the same, but for the shifts, we're only shifting the A values. So here is both like the tens place and the ones place for the A's, and it'll go into the tens place and the ones place for the output. And we're gonna put that on here. And the same with our logic and our OR, our XOR, our NOR, our NAND, and our XNOR. We're going to have the tens place for the A and then ones place for the A with semicolon of B of the tens place for the B and the ones place for the B, and that's going to equal the output. And I have yet to do that yet, but we got our pseudocode right here. And then for our comparison, we're going to have to add because on our, we're going to have to add our Boolean expression coming out of our code. Because right here is the data bus, but like right here, underneath that is the Boolean expression for these two comparison, because it can either be it can be for the comparison, it can either be false but equals, or it's true. I'm going to be getting rid of this false equals, because if for a greater than, it's either greater than or not greater than, so it's either true or false. But they can find out if it's equal by just doing true and true, by changing it to the comparison of the equal. So when A is equal to B, it's going to be true. Where A is not equal to B, it's going to be false. So if A was not greater than B, it would be false. But it would also be false if A equals B. But they can find out if that is true by doing the comparison. But I haven't really thought too much about that yet. But right here I have our to-do list, and right now, for the next little bit, I'm going to be working on fixing our subtraction. We're going to need to add negative numbers, as I was just showing. And then our division needs to have real remainders, and our multiplication, it needs to be, there's some sort of glitch going on with our multiplication, as I just showed, but it's also going to have to add more, we're going to have more digits for a multiplication, because like if we want to go up to 99 times 99, which would fit on these, we're gonna need more space. Also, yeah, we're gonna need at least 4 digits. Also, I'm thinking about like capping all the input numbers at 99, but we haven't talked about this as a group yet, but just so we can keep it on the hex display. But if we want to get rid of these 99s, we don't necessarily need these hex displays. We could maybe put more numbers up into this, up into the A and up into the B, and maybe get a longer string or longer float value. Also, another thing I'm going to be doing is building in the LCD variables for the shift, rotate, and logic and comparisons. And honestly, this shouldn't take too long. Really, the only hard part was actually making it variable at first. Like, this took me so long to figure out how to actually be able to change it like that. But now that we have a working prototype for some of the different opcodes, we'll be able to switch it up pretty easily. And also add in the Boolean functions for the comparison, the equal to signs. All right, so that's all I have. That's all I'm working on, and I appreciate my group mates. And sorry I'm not there to help present tomorrow. Thank you.